Hello guys, my name is Antons. I'm from company MikroTik from Riga, Latvia. Today we will talk about our new 60 GHz devices called wireless wire. At the end of presentation, I hope you have time for live demo, see how it works, that we are not making all those graphs up, that they are real life performance. So, let's talk a little bit about wireless bands. Currently, MikroTik supports 3 bands, 2.4, 5, and now this is our first 60 GHz device. So, let's talk about some points of each band. 2.4 GHz, it's a very crowded spectrum. It's pretty much impossible to use for point-to-point solutions in very crowded areas. There's low available channel count that makes it even more crowded. But it can go higher distances than 5 GHz or 60G. It penetrates through objects very well, and that's pretty much everything about 2.4. 5 GHz, there is problems with dynamic frequency selection and radar detection. You have always take that into account because false alarms will happen. No matter what frequency you use, how you use it, false alarms will happen. And it's on any device, not only ours. Rapidly increasing channel width. That means everybody wants most throughput to 5G, so everyone's setting it to 80 MHz channels, taking all the spectrum just for themselves. It provides high throughput, and it has more available channels. 60G. Let's talk about elephant in the room. It won't go very far. There's a physical property called oxygen absorption in that frequency. So we are selling this kit as 100+ meters. What does it mean? It will work for short distances up to 100 meters with MCS 8 rates. The further you go, the more fade there will be. We have tested these devices in 200 meters. We have tested in 150. Sometimes you can get full 2G speeds through it, but sometimes you don't. It depends on the environment where you are implementing it. In Latvia, it's very rainy, very foggy. Everything makes it much more harder to use. It provides highest throughput. As I said previously, it can throughput 2 gigs of real-life speeds. And it's a relatively free spectrum because everybody is slowly moving towards it, but nobody actually uses it. And oxygen fade, it makes like, yeah, it fades, so it doesn't affect me if someone from 5 kilometers away are using it. So let's talk about a little bit of wireless protocols. 802.11 supported by all bands currently by MikroTik. It's GSMA with collision avoidance. It's easy, fast, and compatible with pretty much everything. It's like your home router is running this protocol. NV2, it's time division multiple access used in mobile technologies. It has some pros, it has some cons. You have to test it. If it works for you, you're in the money because it's secure. It's not affected by, if you have heard about VPA2 cracks recently, it can't affect. It's our protocol, it's proprietary, so it's secure. N-stream, same as NV2, but it's a little bit old for nowadays standards, but if it works for you, use it, you'll be happy. About modes, you can run your router. There's access point bridge mode. It's for more than one client access for your access point, and there is bridge mode. If you buy CPE device, it comes with level 3 license. It means you can bridge your network, but only one device is supported. You can upgrade license, or you can just buy access point bridge to support the device with level 4 license. Station modes, you see there's a lot of modes. Each has its usage. Station is the basic mode where you connect as a client to the access point, but no bridging is supported, so you have to route your network. If you want to avoid it, you can use station bridge. It works only in MikroTik devices, to MikroTik devices. Are using things wrong with my mic? Maybe Martins can bring me another one? Sorry for that. Station modes, you see, there's different ones that masquerades MAC address to provide that bridging. So, yeah, station, no level 2 bridging, you have to route. Station VDS, it works only in router OS, creates separate interfaces, and works on our protocols, currently not on 60G, fortunately. Station privilege, so source MAC address is replaced, destination MAC is replaced. And don't work on NV2 because there is no need of it. So you can just set it to station bridge and bridge it. Wireless modes. For 60G, you just have 3 modes, so you don't have to go through all that configuration, don't have to read it, don't have to understand it. You're just having master, slave, and sniff. If you want to connect 2 devices, set one as a master, other one as a slave, and you're ready to go. It all configurates under wireless interface Y 60G menu. And so minimum configuration is you set just SSID, and that's it. Enable interface, and you're ready to go. You can set a password to secure your network. So, wireless wire. In front of me, I have a wireless wire kit. Those are 2 devices sold together as a kit. Martin has told you about it since his opening presentation, but we will go through some of main points one more time. So it's pre-configured. That means that you are buying it, you can just replace it cable with this device. It's the fastest CPU for outdoor device by MikroTik up to date. It's based on ARM architecture. It uses only 5 watts of maximum power, and it's range for 100 meters or more. Soon we will have another devices, also with 60G support, going further than that. Not telling you exact distances because we're still testing, but it will be much more. It supports beamforming, and now it supports point-to-multipoint. What does beamforming mean? There are 32 antenna modules on array, and the router selects ones that have the best signal. So even if your arrangement is a bit off, it fixes it for you. For example, we have camera link set up also with wireless wire. Devices are not pointing each other. They're just reflections, getting reflections and using the beamforming technology. If we compare this device to other our devices, you can see those are real graphs. Yes, it can do more. It was just for presentation. In lab setup with 2.4, I could get up to 256 megabits per second. It's using dual chain cards. With 5G, I could double it even more. It's also with dual chain cards for point-to-point triple chain. It could be used, but there is some pros and cons with that. And you see 60G. that's a lot of increase. It's like 2 times more one way and 4 times if you count it together. 60G is limited by Ethernet interface. Wireless part works better than Ethernet, so it can pass more traffic than Ethernet. That's why we call it wireless wire. So you can just cut your cables, replace it with paired device, and enjoy all the throughput you can get. It's a very great value for short wireless links. Sometimes even in places like this, when you're not allowed to move your cables, or you can just put 2 devices, link everything together, or between 2 buildings. It can go through some windows. We have tested it. Some windows don't pass it. Maybe that's gases inside them, maybe something else. But for short links, and if you see all the throughput, there's nothing that can compare from our. So this is a graph with real life performance. This is a 100-meter link, exact 100 meters, in Riga, Latvia. Today in Riga is -3 degrees. It's snowing tomorrow. So in rainy environments, 100-meter lengths, it's pretty good, I think. So how it compares to wire? We did tests with wire, past traffic, see how it passes it, and later we did the same, but replaced wire with our devices. As you can see, we get pretty much the same results as by running wire, but using wireless technology. TCP connection, you get a full speed. There are no drawbacks. CPU can handle it. You will still have some extra you can use for management, for service quality, whatever you can think of, or for firewall, packet marking. Small packets, yeah, the CPU sometimes, but you see how much it is. It's like 2 million packets together. It's a lot. It's very lot. We did tests with Xena. That's real testing equipment. TCP tests was done with Hyper-3. Point to multi-point support. We added experimental support in RC releases. We are not adding it to stable yet, as today, as tomorrow, but we will soon add it also on current version after we do some more testing and checking if everything works as expected. You need to upgrade one of your devices to level 4. As I said previously, if you want more than one connected client, you need level 4 license. Maybe in future we will make access point device to support CPEs. Maybe. Connected clients are treated as individual interfaces. What does it mean? When client connected, virtual interface appears under master 1. So you can add some more configurations, and it's easier to configure that way. So point to multi-point performance. We took one access point out, took 2 clients, and see how far we can go. Devices are equipped to a 60-degree antenna, but we could make more than that. As you can see, the distance is close to 100 meters. Both devices receive 200 megabits of full duplex traffic. It can do more, but for testing purposes, we used only that much. And we moved devices from each other to see how far we can go. So we got to 124 degrees of coverage, and we ran out of space. We don't have so much space as in Saudi Arabia. Latvia is a small country, especially in Riga. If you find a good place to test, you're really lucky. Sorry, jumped one. So this one shows with 4 clients you can get up to oh sorry, this is mistake, not 400, 200, but still that's really good. So you can do the same as in previous, but with 4 clients, each one receiving the 200 megs duplex. So it's total 400 to each client. So we run out of slides very quickly. We will do live demo, but we will talk a little bit about testing, how testing is done, how it should be done, and maybe we will do the right way afterwards, maybe not. See how it goes. So it's not preferred to run bandwidth test tools on testing devices. If you have 2 devices, don't run bandwidth test from one device to another one. If you're testing throughput. If you're testing stability, yeah, it's okay. But if you're testing throughput, you have to run through link. So you have to add powerful devices before and after wireless link to test it correctly. You can use our B-test that comes in Router OS. It's a great tool. You can do TCP, UDP, various packet size, but it's very power consumption on the CPU. It uses a lot of CPU. It runs on 1 core, so it's better to use x86 Router OS or some powerful Router OS device. You can make traffic generator. We'll make traffic generator templates and run traffic generator in our live demo. You can use iPerf and iPerf 3. I don't like very much iPerf 3 because of some limitations about connections, but it's still a good tool. There's plenty of other tools. There is speedtest.net, but you know that it shows only one-way traffic. It don't send both ways at the same time. If you're testing your ISP, you know that they can cheat with that tool. If you manage the network that way. So we have 2 devices in front of me. One is configured as a master, other one is configured as slave. Actually, I'm really afraid of live demos. I have seen a bunch of them on YouTube. They never work well, especially with wireless devices. I hope today it will be different. We have another wireless link running in background. I hope they don't interfere. So, master device has address from same subnet as slave device. Addresses are set to V60G interface. It's not set on bridge. If you buy your devices as pre-configured kit, there are addresses already set on them. There's already passwords set on them. You don't have to configure anything. You can do it if you want, but you don't have to. In this test, we are not sending traffic through Ethernet. We are not doing it the right way. We are running traffic generator on the board. But because this device is very powerful, it can generate 2 gigs of traffic without any problems. And we will make one trick to send traffic in loopback mode. We will send it to device and receive it back. Traffic generator also shows lost packet counts and stuff like that. It's really good for troubleshooting. It shows latencies and out of order packets. So we're making packet template. To start with traffic generator, first of all, you have to make packet template. You're adding IP destination. So we are sending from master device. PC is connected to master device to slave device. So we are sending back to master. So we are sending to the same IP we are sending from. We are setting gateway as a slave device and adding source on X6. There is no such address in network, but it has to be, so layer 3 networking works. And we are adding a name for it. UDP destination ports are for load balancing. So you never send large amounts of traffic through to one port. In real life, it doesn't happen very often. So we are just adding from 100 to 300. So It's 200 destination ports. And later we are making stream. Stream is where we are setting speed, naming it for easy to understand, adding packet size, and providing name of packet endpoint we are going to use. We can set up 24, 25 streams max, but that's enough for testing. So to start traffic generator, you can run traffic generator start. To stop, you just run stop. You can use graphic user interfaces for that, but command line is not going anywhere. Everybody working in networking knows that command line is a great tool, especially if you're testing, especially if you're debugging. It's the same from graphic user interface, but command line is the way it should be done. You can add extra arguments. For example, if you don't want to run 900 megs, you can run it with quick, set up like 300 megs, put different packet size, put duration, put other things that you need for your test. So, sorry, that's not it. We're gonna run it. See it, how it works. So, this is the master device. We can export, check that everything matches. Yes. Also, if you're making packet templates, always check if MAC destinations layer 2 stuff is matching. If you are changing devices, it's preferred to run set find. It assumes MAC destinations, MAC sources once again. Oh, it's typo. So, first of all, run quick test with 5 megabits per second. So, if I send 5 megabits, in theory, I should receive 5. So, something's wrong. As I said, live demos are hardest part. So, you see, we are sending 5 megs, we are receiving 5 megs. We can put duration to set average, like 5 seconds. So we are sending 5 seconds, 5 megs, and receiving 5 megs. So later we can compare how much we send packets. So there's transmitted package count, and there's received package count. Everything matches, no packet loss. So let's put something more extreme, like 500 megs. It's 1 gigabit throughput. Same, 5 seconds, received, transmitted. Everything works fine. So let's play a little bit more, see how it performs under higher loads. So, for example, packet size. Try different packet size. So, small packet performance, 100 megs of 60 byte packets. So, you see, it's sending 208,000 packets and it's receiving 208,000 packets. So, but I promised you 2 gigabit throughput. So, let's make 2 gigs. Let's send 900 megs both ways so we don't get disconnected if some packets are out of order. So you see, it's 900 megs transmitted, 900 megs received at the same time. If we open interface, we can open traffic, see how it's going. So here you go, close to 2 gigs of total throughput to small devices. Device kit price, list price is $200. So it's cheaper to run cable in some cases, especially in hard to reach areas. It's running stable. So it's generating traffic and it's sending traffic. Let's see how our CPU is doing. %36%. So we have a lot of room to grow. So to show you that I'm not breaking it up, maybe I can go through it. You know that 60G don't go through objects. Beamforming is working, but it should. Yeah, beamforming is working too well. Let's cover the client device's hand. Wow. Still working. Amazing. Wasn't expecting it to work so good. Yeah, so let's check if everything is okay. If everything is working fine. We have some drops. It's a short distance. Beamforming finds nearest path. It can go around objects in small distances. On higher distances, if something goes in its way, the link may fall down. So let's stop and let's try small packet performance. 2 gig throughput, yeah, maximum. I'm sending a little bit less so I don't lose connection to the client device. Yeah, there's 7 gig. MCS allows it, data rates allow it, but it's limited by Ethernet interface. So why should you go higher if you have only 1 G Ethernet? In future, we'll add SFP ports or something like that to get the full speed. So it's sending 1 million packets both ways. So that's our wireless wire. Let's talk a little bit about tools for wireless we have provided. So there is this is country Latvia. This is where we're from. We are in city Riga, and we have made this calculator to calculate link possibilities. So you can add your devices, set up frequencies, set up gains, receive sensitivities, everything. And it will show if the link is possible, if it will work, and how well it will work. There is also elevation graph. Take it a bit of grain of salt, because not all data is correct. If there wasn't building yesterday, there may be tomorrow, something like that. We have also graphs with our point-to-point performances available on MikroTik.com. There is also point-to-multipoint graphs showing link possibilities, stuff like that. Yeah. Thank you for your attention. If you have any questions, feel free to ask. Any questions?
Is the carrier frequency 60 gigahertz, or it's a frequency conversion?
There are 3 channels available. It's actually there's 4 channels. The device supports 3 channels. Mm. So it's 60 gigahertz, yeah. The middle channel is 60 gigahertz or something. You can look it up.
All right. Because there was a device that doing the from 5 gigahertz conversion to 60 gigahertz conversion.
No, there is no conversion going on.
Okay, very good, very well.
Any more questions? Last page. Yeah.
No. Calculator. Calculator web page.
Yes.
It's live work now.
Yeah, it's working
Okay.
now. You can connect it. You can see address up here, mikrotik.com/calculator. And it's replacing our old calculator where there was no map possibilities.
Very good. Very good. Thank you.
Any more questions?
What is the expected maximum distance it can reach?
Maximum distance depends on your usage. If you want full gigabit stable 99.9% of the time, it's 100 meters. If you want to go further, you can go, but there will be losses. We have tested in 200 meters. It's still linking. It's not full gigabit, but it's MCS for that rate, so you can still use it. In Saudi Arabia, it should be much more easier because 60G, it's oxygen fading. It's a frequency not made to be used in point-to-point setups. It's frequency made to be used in homes, not to affect other people. So we are kind of pushing boundaries here. We are using the worst frequency for this, but we are still very, I think we have done a great job with that. One more thing, 8211 AD protocol used in this one, it's slowly opening. Countries are slowly accepting it, so it should be unlicensed overall. So check your local regulations. If it's allowed in your countries, you don't need a license for it to run. You can either use it indoors or outdoors, and just check if your country allows that. Any more questions? Yeah, please.
Any plans for 24 gigahertz?
Oh, maybe, but that's licensed links and
24 and 60 count as LAN licenses worldwide, I think. 24, 5 gig at 2.4. These count towards the LAN license at the moment, at least worldwide.
yeah.
Are you planning anything for 24?
Maybe I can discuss this one because that's you can write us an email, but we will still don't give you an answer. If we will announce it, yeah, but right now we are working on different projects, but we can't announce everything.
Okay, what's the top modulation
On this kit, MCS 12. Right now it's locked to MCS 8 just because of Ethernet port, but you can reach MCS 12 with some changes. Maybe we will make them public, maybe not, we will see, because it's working fine with MCS 8 right now. It's providing full gig, as it should be, and you can't pass more through it, so maybe in future products will unlock all the data rates. More questions? Or that's it? Yeah, thank you for your attention.